I know, woman, to pump me up. I know. No, Melissa, see. All right, let's talk. Share my entire window, my entire screen. All right, here we go, kids. Today, we're going to start with your atomic structure worksheet. That is what we are starting with, your atomic structure Pogil. Go on the googly wooglies. I meant your School of Geologies. Quickly get your lives together. Quickly get your lives together. Quickly. I'm sorry, but we cannot wait on you today. We cannot. I apologize in advance. If you're ready to rock, say let's go. You're ready to rock, say let's go. That's one person. You ready to rock? Quickly, let's move. All right, here we go. This atomic structure Pogil was a fun time. At least I had fun. It was great because you actually had to critically think. Those of you who did not do this activity, sucks for you because it was a great time. It really was. Because you actually had to figure some things out. Let's look at information we've been given to us. A lot of you struggled because you tried to open this in the Schoology app. Always, you need to open these documents from the Word app on your computer. First, you go through Schoology and create the document. Then you're going to open it in your Schoology app. Does everybody understand? So you should be on the Word app of your computer. Here we go. It says, be sure to type your answers in a different color. The atom, the nuclear atom. What is an atom? That is the goal for today, to determine what an atom is. Here we've been given a key. What does the black dot represent? What does the open white circle represent? What does the gray circle represent? Neutrons. Okay, here we go. We also know that 1 AMU, we don't really know what that means right now, but I'm going to let you know. If you want to make a comment or make a little note over here, an AMU is an atomic mass unit. Is an atomic mass unit. Atomic mass unit. Do you normally wear glasses? I like them a lot. They look nice on you. All right, here we go. Next, we know that the nucleus of an atom contains the protons and neutrons. They gave us this information for free. Say thank you. Thanks, sweetie. Okay, now we have some different things. We have hydrogen, and we have a 1 with the hydrogen. We have a 2 with this hydrogen, and we have a 1 hydrogen minus, but this hydrogen is called an ion. What else have you noticed about these 3 versions of hydrogen? What's another observation? What you got, Justin? They do have different masses. Good. What you got? All of them have at least 1 proton. At least. Do any of them have 2? No. So they all have 1 proton. That's good. No, that's good. Let's look at these carbons. Anything about these carbons that we notice? All have 6 protons. All right, let's boogie on down to our questions here. And they tell us here that 1H and 2H are isotopes of hydrogen, 12C and 13C are isotopes of carbon. Interesting. Here we go. It asks us right here, how many protons are found in 12C? What's my answer? 6 protons. How many protons are found in 13C? 6 protons. How many are found in 13C minus? 6 protons. You should be checking your work at this point. No one should be furiously typing because this is already done, right? All right, how many neutrons? Yes.
One specific thing, do we need to include the P plus? Like for that first one, do we have to include the P plus or?
Yes. It just adds a little bit more clarity. Plus 666 looks really scary. Okay, how many neutrons are located in 12C? How do we determine this? Yes, literally it told us how many are right there. It says 6 are in 12C, 7 are in 13C, and 7 are in 13C minus. So let's go ahead and put that in. We have 6 neutrons in 12C. We have 7 neutrons in 13C and 7 neutrons in 13C minus. How many electrons did we have here, everybody? 6 electrons, then what? Then what? Good. Good, good. A lot of you guys are furiously typing, which gives me a vibe that you didn't do this assignment, which stresses me out. You should be correcting your work, not simply typing your answers, but it's okay. What feature distinguishes a neutral atom from an ion? Good job. A charge. So being more specific, because we are scientifically writing, a neutral atom does not have a charge. An ion has a charge. Provide an expression for calculating charge of an ion. I want to see what you came up with. What you got over there? Not you, Justin. Minus electrons equals the charge. Beautiful job. That is exactly right. And it spells PEC. If you need help remembering it, it's PEC. PEC, protons minus electrons equals the charge. Based on the model, why do all carbon atoms and ions have in common? What do they all have in common? You answered this earlier. Good job, 6 protons. What do all hydrogen atoms and ions have in common? Good job, 1 proton. All right, next. How many protons, neutrons, and electrons are there in that one atom of 1H plus? Ooh, I heard 2 different answers. The part of the answers I liked, 1 proton for sure. How many neutrons? 0 neutrons. Okay, there's an argument between 1 electron and no electrons. The formula for a charge is the protons minus the electrons equals the charge. So if the charge is +1, and you know we're going to have 1 proton, 1 minus what gives you +1? 0. So there will be 0 electrons. All right, what is the significance of the atomic number, or Z, above each symbol on the periodic table? 1 second, let me see if anybody else actually did this assignment, guys. You guys crushing it. What you got? Beautiful job. It indicates, wow, forgot the end. The number of protons. Does anybody else have anything to add to this? What else does it do? There's one more thing it does. Anybody else have a guess? Whoa. That would be the charge. But what I was going for is, you know how like if I have an atomic number of 5, I'm always going to be boron. If I have the atomic number of 6, I'm always going to be carbon. So it helps to identify the element that you're working with. Make sure you add that to your work. Hey, sweetie. Good morning. Oh, sorry. Hey, sweetie. You having a good morning? Yeah. I think somebody stole your chair. Oh, it's back here. Or this one, whichever one you grab that one. All right, here we go. Number 7, based on your answer to QT6, which is number 6, what do all nickel atoms have in common? Give me somebody fresh. Somebody fresh. Don't make me get aggressive and call on random people. Fresh, fresh, fresh. The number of protons. Good job, Dev. The number of protons. They will all have the same number of protons. Hey, sweetie, we're on the atomic structure, Pogil. I'm going to post what we've done, so don't sweat it, okay? All right, number 8. What structural feature is different in isotopes of a particular element? I'm going to start cold calling you, and it's going to get aggressive. I know you know the answer because you did your work, and I'm proud of you. I'm going to start cold calling. Yes. Go ahead. Okay. It is different. That's good. But what structural feature? I want to know specifically. The number of neutrons. Good job. And that affects the mass number. So yes, but it's asking about the feature. So that feature would be the neutrons. The number of neutrons. How is the mass number, which is known as A, which is the left superscript next to the atomic symbol as shown in the model, determined? How can we determine the mass number? Let's look at these examples. The mass number for 12C is 12. Superscript means up in the air. Subscript is down low. Anybody? Go ahead, Atlas. Protons plus neutrons. Very good job. Protons plus neutrons. Number 9, protons plus neutrons. Where is most of the mass of an atom? Within the nucleus or outside of the nucleus? Everybody yell it out. Yay! Look at you, class. That was good. All right, explain your reasoning using grammatically correct English sentences. Who's got it? Who's got it? Who's got it? What you got? Beautiful. Well played. Inside the nucleus. This is how I'm going to write this. Adjust your answer accordingly. Inside the nucleus, the protons and neutrons have masses that are significantly larger than that of the electron. Therefore, their location will have more impact on the mass. She knows. She knows. I know. She knows. I know. She knows. What does she know? Perfect. I'm gonna keep rocking. What's your question, Haley? They're different colors, but whenever I go to Schoology, it's okay. I'm checking your Word document. I go in and look at your actual Word document at the end of this. Okay, cool, Captain Kittens. This is what your test is gonna look like. A chart like this, okay? I'm kind of sort of fibbing, but not really, because I haven't made your test yet. We're gonna see how this week goes. All right, so you've only been given a small portion of information. We've only been given the isotope. For this one, we have 31 phosphorus. We need to figure out the atomic number and the mass number and the number of electrons. The atomic number, let's start there. The atomic number can be determined by looking at the periodic table, right? So if you need to open up a periodic table, on Schoology is the one that I like. It should be like on the main page. It's the black and white one. You guys know what I'm talking about? Periodic table right here. Yeah. This is the one I like. If you use another one, you're gonna, I mean, you'll be fine, but it's not cute. All right, so here we go. I know she knows. All right, so right here we have 31 phosphorus. Well, we already have the atomic number. Yay, us. The mass number. Well, this is a superscript over here, this 31. So that's going to actually be our mass number. Does Miss Stanley know that it's not perfectly under here? Yes, I just pressed space a bunch of times in order to fill it in. There you go. There you go. Yes. All right, number of electrons. Earlier, we found out that our formula for electrons is what? Do you need your computer? You have your computer. Do you have your computer? Okay. All right. So we learned that the formula for electrons is what? Protons minus electrons equals the what? The charge, right? So if I know that there's no charge here because there's no plus or minus like there is in this nickel one, that means my charge is going to be 0. So that means that my protons and my electrons are the same, right? Well, the only thing I know to determine the number of protons is the atomic number. You see how we're putting everything we just learned into one little chart? So if my atomic number is 15, how many protons do I have? 15. If I have 15 protons and my charge is 0, 15 minus what gives me 0? 15. So that means I have 15 electrons. How's it going? Okay. Now let's talk about oxygen. Well, we don't have an atomic number for oxygen. We need to look on the periodic table of elements. Oh, that was aggressive. Looking here. Oh, whoa, whoa. Is my atomic number 16? No. What is my atomic number? 8. This is my atomic number, 8. So over here, I have an atomic number of 8. My mass number is what? No, it is not. We use the isotope, and that was a great, I love that you did that. When I give you these problems, I will know if you know what you're doing or not, because if you give me a decimal or a number that comes straight off this periodic table, then I know you don't know what you're talking about. The mass number comes from the isotope. So right here, our mass number for this one is what? 18. Anybody have questions about that? All right, here we go. Next one tells us that we have an atomic number of 19. We have a mass number of 39, and we have 18 electrons. Well, what element has an atomic number of 19? Close. Not mass number, atomic number, atomic number. Potassium, K. All right, so we know our symbol is K. 39, yes, it would. Why is it 39K, Duh? The mass number, good job. So we have 39K. Who wants to try to determine the charge? Go for it. How did you get +1 given the information on the table? Good job. 19 minus 18 gives you +1, and that is in fact your charge. Now, generally speaking, we do not write ones at all, ever, unless it is a mass or something like that. So therefore, you can just put a plus sign. How did I what? I just shift and then equals button. Oh, I was like, I just shifted and then the equal sign. I'm sorry. We did the protons, which is the atomic number, which is 19, minus the number of electrons, which is 18, and that gave us +1. So positive things, protons, minus your negative things, which are electrons, gives you the overall charge. So that tells you how positive or how negative something is. So 19 minus 18 equals +1. So that's why it's +1, but we don't usually write the ones, so it's just plus. Got it? All right, focusing in. I want you to do nickel on your own. Do you think you can handle it? Yes. Good. Try it. Okay, I recorded an not aggressive, it's a cute video for the remainder of these problems, and that will be your his homework. Any questions? Perfect. This is homework. Go ahead and click save on this. Click save on this. All right, what I'm going to do is I'm going to paste the link of this copy of the one that we did together right now. I'm going to share it in an update. And I'm going to title Atomic Structure Pogil Answers Through Exercise number 1. All right, we're going to transition. Are you ready? Okay, I just posted that link to the document that I just did in case you missed something. Okay, 1 down. Next up, let's go pull up your lab. We have like 4 labs to look at today. I'm just kidding. It was an exaggeration. Actually, we're done with lab 1. We did everything for lab 1, did we not? I thought we did. We did, right? That was lab 2, right? Okay, cool. Wow. Okay, guys. That's where we're headed. I thought we had to do that on lab 1 too, but look at us. It's giving I didn't post the right thing, but I'm not mad. Okay, let's look at lab 2. Yeah, we're about to answer those lab 2 questions, and I thought we had question to answer on lab 1. Hello, children. The first lab? At the end, weren't there questions at the end of lab 1? Did we put the data into the data table though? And we put it into Excel? Okay, so the point of us doing that lab, let me bring y'all back. Okay, so the point of us doing lab 1 was to practice data collection, right? I wanted you guys to be able to put data into Excel documents, which struggle bus, looking at your documents a little bit, struggled, but it's okay. It looked cute regardless. And then what's going to happen is next unit, because we need to move on, next unit what we're going to do is we're going to use evidence to identify a substance using the data that you collected, right? So intensive properties, answer me this. Intensive properties, do they change with the amount of substance or do they not care the amount? They just care about the type. Intensive. Intensive properties only care what the substance is. They don't care how much is there. So for example, if my intensive property is color, it doesn't matter that I have 2 pairs of goggles, they're orange, right? So an intensive property would be that they're orange, color. Another intensive property is density, right? So the property that you analyzed in lab 1 was density, because you couldn't tell me what a substance is just by looking at what color it was, because you had some clear ones, had some blue ones, had some yellow ones, you had some thicker ones, some thinner ones. But the point is you couldn't identify it without looking at intensive properties. We'll analyze it a little bit deeper, but the main one we need to focus on today right now is evidence of a chemical reaction. Go ahead and pull up that lab for me. Evidence of a chemical reaction is the lab you're pulling up right now. Yeah, I know she knows. Ready? Why? Oh, child, please. Welcome to school. Here we go. All right, somebody explain to me. Actually, let's have an aggressive volunteering. We are going to aggressively volunteer yourselves. If you do not volunteer, that does not look good for you. All right. Who wants to volunteer for my first question? Who's volunteering for my first question? All right, Justin, you have the first one. Justin, what is the physical characteristics of the hydrochloric acid before the reaction? Thank you. Who wants my second question? All right, Kyla, here you go. What was the temperature change of this experiment? 9.8 in the positive direction or in the negative direction? Positive. So who wants my next question? It's not going to be the exact. It's you did 2 pieces of different metal. and you did 2 different experiments. It's the same experiment, but you're going to have different results as long as it got hotter. If it got colder, then we got a problem, right? So, all right, so knowing that your temperature got warmer, is this an endothermic or exothermic reaction, Atlas? Endothermic or exothermic reaction? Or number 1, it got hotter. Phone a friend if you need to. Close. Exothermic. You need to make a note here, kiddos. Make a note. Exothermic reactions get warmer. All right, let's look at number 1. It says list the elements for the given reactants and the number of atoms of each. List the elements for the given product and the number of atoms of each. Based on the difference in the number of atoms between the reactants and products, predict the unknown products. All right, so for reactants, what elements did we have? Good. How many hydrogens did we have? Good. This will look really cute in a table. Can we do that? Do you guys know how to put a table in your document? Okay, go to insert up at the top, the ribbon at the top, and go to table. And then do like a 2 by 4. This will be reactants. This will be products. All right, we had hydrogen and we had 2 atoms of this. How many atoms of chlorine did we have? 2 atoms. And how many atoms of magnesium did I have? All right. Who wants my next question? Isabella, you've been chosen. What are my products of this reaction? Give me the 2 that you know for sure. Good job. Who wants my next question? Go for it, Rebecca. How many atoms of magnesium were in this reaction? Good. How many atoms of chlorine were in this reaction? Good. Now, here's the question. What does the other product have to be? Because you're not, go ahead. Good job, H2. The missing product is H2. If you want a subscript, you have little 2s up here. Up here underneath your font, under the home ribbon, it's the little 2. Okay. Why does this prediction make sense? Are you on the phone?
I'm charging.
You're on the phone? Does that make sense? To be on the phone in the middle of class? Jeez. Lord have mercy. All right, now it says to calculate the temperature change. Did the temperature increase or decrease, everybody? Increase. Oh, look at this. OMG. Who wants number 3? You can do this. You can do this. Who wants it? Someone I haven't heard from? All right, take it away. You got it. Why? Yes. From the system. Good. As evidenced, watch how I write this, everybody. As evidenced by the increase in temperature. Do you see how I use the experiment to defend my answer? Do you think I will just accept the answer exothermic? Why? There's no evidence there. You're basically a big crap talker. Nobody likes a crap talker unless you're playing sports, and then you better defend McGavick like you never did before. All right. All right, number 4, what 2 things happened during the reaction that indicates a chemical reaction occurred? 2 things occurred. Who remembers this reaction? This is the one you put the piece of magnesium metal into the clear solution. What happened next? Bubbles. Bubble. Bubbles. And what? Yes. Temperature change. So, right off the bat, okay, you do not have to put that many L's and S's and bubbles, but it does show. I have a difficult question. Who wants it? I mean, scale of 1 to 10, she's looking at like a 4. It's a good one. That's a good question, but it wasn't where I was going. That was a very good question, though. Answer it. Where did the magnesium go, Kyla? Where did it dissolve into? Good job. Now, we know what happened to the magnesium, and we know the other product was hydrogen, but what evidence do we have that there was hydrogen? Because we know the solution is magnesium chloride. What evidence do we have that hydrogen gas was created? The bubbles. The bubbles. Bubbles have gas in them, and that gas was hydrogen. Did you know that if we had taken a match to those bubbles, it would have gone poof? Should have. But we didn't. All right, so let's go to the second one. This was a fun one, and we have to finish in the next 8 minutes. Here we go. This next one. Did the temperature, this was the copper chloride. This was the blue one. This was a cute one. The blue one. Put your phone away. The blue one. What happened with the blue one? Right. What'd you do with it? What'd you do with it? You did. Some of you didn't swirl the beaker around, so nothing happened. But what was supposed to happen? Disintegrated, right? There was no obvious piece of aluminum metal left, so let's figure out. Guess what we're going to do? Same little table from earlier. This time we have 3, so we're going to do the same 4x2. Reactant. Products. Notice that my tables have labels on them. Each column has a label, right? It's not just lists. Who wants to fill this table out for me? You got it? 3 coppers. How many chlorines? Close. Multiply. Good. 6 atoms. How many aluminums? 2 atoms. Guess what this symbol is not? It is not artificial intelligence. It is AL. It is not AI. For the love of Pete. All right, so indicated by a reaction, we know that we're still going to have aluminum, 2 atoms of it. We know we're still going to have 6 atoms of chlorine. So what does that mean my solid is? Copper, not copper 3. It's just going to be 3 atoms of copper, which means it would be U. Our solid is copper. If you recall, looking at this lovely substance, there was something red, bless you, coffee. There's something red in the beaker. You guys were like, what is that, Miss Stanley? And I was like, just keep living. It's
Teachers, please find this interruption. I need the Life Science and Law seniors from the health pathway to come to the south cafeteria. If you have your permission slip, please bring that.
oh God. Tell me that's none of y'all.
Oh, no.
Okay, I was about to put it. Cross here.
What do you mean?
5 minutes. This drive, I guess. Oh. Let's insert.
Yeah.
All right, next up. Calculate the temperature change. Tell me, did the temperature increase or decrease? Increase. Do you get the gist of how these questions work now? Kinda. Let's finish up this one. Temperature increase, is it exothermic or endothermic? Why? Because the energy in the form of heat flows out of the system as indicated or as evidenced by what? No. There you go. All right, what two things did you see in this reaction? It did. Did it bubble? Did it fizz? Bubbled a little bit. And temp change. Okay, it's weird that bubbles occurred because there's no gas in the equation. How do you explain the observation of gas bubbles, Justin?
Latent air that was trapped inside of the liquid in the form of bubbles was.
What was in the air? What was in the air?
Nitrogen.
Nitrogen?
Nitrogen.
No. I'm just asking you. I hear you. I just need you to dig a little deeper.
There's nitrogen, carbon dioxide.
In the solution?
In the air. And it was in the solution.
Okay, I'm not mad at what you're thinking. I'm not mad at it. I'm not mad at it at all. I like your train of thought. I'm gonna push back because when I made this solution, I did not whip it to the point that air bubbles were entranced into the solution. The only thing in that solution is H2O and what's that thing called? Copper chloride. There's no air in it. So I want you to make your best guess on this question. Do you think you can finish these questions on your own? I do too. Can I have this by Friday? Okay, let's make a list. Remember when I told you that homework was going to pick up in this class? This is that. Okay, atomic structure, Pogil. That was the first thing we worked on. Let me get that by, because you only have like 4 more to do, like about 6 more questions, and the video walks you through most of them. So can I get that by Wednesday? Can I get that by Wednesday? The one we worked on first. The Pogil. I think I can get that Wednesday, right? And then lab 2 questions. This will be a summative, so please don't half behind it because I actually read them. So don't waste my time. Lab 2, let's have this done by Friday. Is that fair? All right. So save this. Save this and let's X out of it. Let's go to, yes. And it won't let you edit it, will it? Okay, let me unsubmit it to you. Yes. Who is me? I'm just gonna change the due date. I have the power to do that. Oh my gosh, not you guys silently stressing over there. We don't silently stress. We powerfully stress. We vocally stress in this class. I forgot how to do this. Golly. Notes in PowerPoint. Edit. When did I say this was due? Wednesday? Okay. All right, next up, guys. So we've talked about, now we need to talk about these documents. Look at this one that you got from class. This one. This one, this one, this one. Do you have it? On the top, on that front desk by the hole puncher. Get the one that's stapled too. Okay, this one is not on Schoology yet, but it's in the classroom and it is still due, so you need to get it. This one, children.
Oh, never mind.
And you need the stapled one. If you haven't gotten any papers from up front, this one. This is the best review ever. This is what the Pogil was on. Put your phone away. Last time I'm going to say it. Next time I'll just let you be great. This is what your Pogil is on. This back here, if you can confidently form and do this back part using whatever resources you need to, this is the best way to study for this part of the test. If you can do this, if you can answer this graphic organizer, this is the best way to approach this section of the test because it is so well thought out. Miss Stanley didn't make it, but I will take credit for it. You know what I'm saying? We're in that season of life. Questions and concerns. When will this assignment be due? Because it's homework. When the test is. Due on test day, which is Tuesday. Next Tuesday. Next Tuesday. Can y'all believe it?
No.
Me either. Yeah, yes. Yeah. I don't know. It's either that or this week. Y'all didn't want it this week, did you? I didn't think so. I wish, but y'all only got one grade. Some of y'all need another grade. You feel me? So, okay, you got it. Questions? Yes. And you didn't. Yeah, you need to do that. Can you email me to remind me that we said this? Yes. It's going to go on this one because Miss Stanley is going to grade like nobody's business. Question. And you guys want this on this grade. I don't know if you guys, yeah, you guys want this. This is probably a more straightforward test than any of the ones I've ever given. I haven't made it yet, but that's my plan. It's pretty straightforward. It's like, if you can do this, and you can do what we're about to go over, and you can do some other stuff, you'll be all right. All right, next up. Yes, Kyla. When do I want the test corrections? When you come to take your retake? I'm so sorry. You have some rude classmates who are talking while you're talking. Stop talking because you probably have this question, guys. Listen. Okay. When do I want your test corrections? When you come to take your retake, you're going to give me your test corrections. I'm going to give you your retake. And then when you finish, I'm going to staple everything together. Friday. And we have clubs that day. So yeah, that I haven't seen your test correction or anything. We haven't had a conversation. So you got to have a conversation with me before you can just schedule your time. Yes.
We have to, okay. So say we only got like, I had 20 out of 25 on one section.
You ain't gotta retake that part.
Okay, so I can retake.
Only the parts that you messed up
So
on.
for the test corrections, I only have to do the ones that I want to retake.
Correct.
I tried to give you these.
Yes, you did. Thank you. Hey, you did the wrong test correction form, but it's okay.
Mr. Lee, how can we do this?
I have a video I'm about to post for them.
Oh, thank you so much.
You're welcome. You're welcome. All right, here we go. Yes. Yes, we did. I'm gonna talk about it at the end of this. I'm recording, so we need to get to the next part. All right, here we go, everybody. Here we go. Open up this. You should have this written on paper. Do you have this on paper? We already talked about it. All right, here we go. I'm working on this. This is on paper. You should have this on paper. Do you have this on paper? All right, here we go. Basically, what we're going to be talking about today is how to calculate isotopes. Can you guys hear me over here? Can you hear me? Okay. I just want to make sure because people are talking and it's really annoying, but it's okay. It's their grade, not mine, because I've taken this class. Woo! All right. So essentially, we are calculating the average atomic mass. When I say the word average, what does that mean to you? Find that. Okay, if I said find the average, what would you do?
Add up all the numbers, divide by the amount.
Add them up and divide, right? That's implying when you find the average, that's implying that everything weighs the exact same. Like your unit 1 test is the exact same as your unit 2 test, exact same as your unit 3 test. They weigh the exact same. Their abundance or their severity is the exact same across the board. That's not how it works in the real world, okay? When I say that the hydrogen 1 atom or the hydrogen 1 isotope has an abundance of 99.985%, that means that it is 99.985% more likely to show up in the naturally occurring world than hydrogen 2 isotope. What's the difference between the hydrogen 1 isotope and the hydrogen 2 isotope? What's the difference between isotopes? The neutrons. So hydrogen 1 isotope has 0 neutrons. Hydrogen 2 isotope has 1 neutron. Hydrogen 3 has how many neutrons? 2. Okay, so the amount of difference in the number of neutrons is what creates our isotopes. Now, we're going to be calculating the average atomic mass. The average atomic mass is determining what is the average mass of a carbon atom in the world. Why is this important? Do you know what dinosaurs are?
Yeah.
Okay. Well, there's this thing called carbon-14 dating. And essentially, it tells us how old something is based off of how much carbon-14 or the age of that carbon-14 in that item. So they may find some bones and they test it, and that determines its age. Okay. Now, what we're going to be doing is determining the average atomic mass. The number on the periodic table is an average atomic mass. Okay. Like if you look at hydrogen, it's 1.08 or 1.01. That is the average atomic mass. But if you're looking right here, this hydrogen isotope weighs 2 point something. This hydrogen atom weighs 3 point something, but its abundance is so small that it's negligible. Do you think we're going to use it in our calculations? No, negligible means we can almost ignore it. Okay. So the way we calculate the average atomic mass is by doing what it states right here. You're going to multiply each atomic mass by the percent abundance. Do you think we're going to keep that percent as 99%, or are we going to change that percent to a decimal? Change it to a decimal. And then just like we normally do, we're going to add them up. That's just like we do with the normal average, adding them up, okay? And once we add them up, that is going to be our average atomic mass. It's a little bit different than what you're used to, but plenty capable of doing so. Are you ready to work? All right, here we go. We have a symbol and a mass number. That's what we have right here. We have our percent abundance and we have our mass. We're trying to determine the number of protons, electrons, neutrons, and then we're going to write the nuclear symbol. And then at the end, we're going to calculate the average atomic mass. All right, this is C12. That being said, how many protons am I going to have? 6. Good. 6. Does this have a charge? No. So how many electrons am I going to have? 6. All right. My mass number is 12. And the way I find the number of neutrons, if you need to write this up here, mass number minus the atomic number equals the number of neutrons. That's man. See what I did there? Man and peck. Man and peck. Man. Man and peck. Here we go. All right, how many neutrons am I going to have? This is going to be 12 minus 6, which is 6. Wow. Our nuclear symbol is the mass number, the symbol, and the atomic number. If you need to write a note over here, do so. Mass number. Mass number is on top. Atomic number is on bottom, and then you have the symbol right there. Questions? All right, let's try this one. This is still carbon, so how many protons am I going to have? 6. Do I have a charge? No. So how many electrons am I going to have? 6. Neutrons is mass number minus atomic number. Well, my mass number is 13. My atomic number is 6. So how many neutrons do I have? 7. Now let's do our symbol. Mass number is on top. What's my mass number? 13. What's my atomic number? And what is my symbol? Because it's quicker than us having to look it up on a periodic table. We could see it and know immediately. It's just for ease. The number of protons. All right, here we go. The next one, we don't have our mass number. We don't have our symbol, but we know it has 6 protons. What element has 6 protons? Carbon. That means our symbol is going to be C. What is the mass number? 14.00, but we're going to round off to the nearest whole number. So it's going to be 14. So C-14. Questions of how I got that? Cool. How many electrons am I going to have? Why? Beautiful. How do I know I have 8 neutrons? There you go. And what does my symbol look like? What's in the air? And what's on the floor? What's my symbol? Beautiful. Now for the fun part, because that was fun, but like this is really fun. Average atomic mass. This is where we're going to take our abundance and multiply it times our mass. So our very first one has a mass of 12.00. What is the abundance that goes with 12.00? 98.93. Turn that into a decimal, and it's going to be to the left, Beyonce, your percentages. To the left. So your decimal is now 0.9893. You're going to add that to the next part. What is the next mass? Good. What is the abundance of that one? 0.0107. Does everybody see how we got that? Now we're going to do the last one, but do we need to do the last one? Why? Negligible. All right, put that in your calculator, Nader. Let's see what we get. Make sure you use parentheses. Yes. This one? Because when you move it 2 times to the left, you're left with an empty slot. So you need a 0 as a placeholder. Good question. Very good question. Very good question. The charge, you would see a symbol. Like if there's a symbol, there will literally be a symbol. Like a plus sign or a minus sign over here. Or, say it again. The charge, what does the charge do? It alters the number of electrons, not protons. It's protons minus electrons. So if we had a charge of +1, then it would be 6 minus what equals equals +1, and we would have 5 electrons. If we had a charge of -1, then it would be 6 minus what gives you -1. So you would have 7 electrons. But we don't have a charge. So positive protons, right? So you're positive, you have 5 positive things. Negative things cancel out positive things. So if I have 5 positive things, 5 negative things, they all cancel out to equal 0. If I have 5 positive things, but only 4 negative things, that means I'm still positive by 1. If I have 4 positive things and 5 negative things, that means I'm negative by 1. So they cancel each other out until they don't. That makes sense? This just doesn't apply here because we don't have any charges. You still what now? Okay, draw 5 plus signs on your paper. The plus or the minus is given in the problem. Like it would be given to you if it has a charge, or you would determine the charge by the number of protons and electrons. Like if I said you have 7 protons and 6 electrons, what is your charge? Then you would say I have a charge of +1. All right, what's my average atomic mass here, everybody? What? What? Okay, I got 12.0107. Yes, okay. Sig figs, 4 spots. So this would be 12.01 AMU. Those are your units for this unit. AMU, average atomic mass unit, average mass unit. Atomic mass units. Dear God, that was low, bro. Man, I just stumbled through that. That was aggressively horrible. All right, next one. Do you guys need help with this portion of it?
No.
No? Yes or no? No? Anybody need help with this portion of it? Okay, so let's do this average atomic mass down here then. All right, so the first mass is 38.96. What abundance goes with 38.96? Good. I'm going to Beyonce to the left, to the left. So it's going to be what percent abundance? Now we're going to add it to the next one, which has a mass of 39.96. I'm going to Beyonce this one too. To the left, to the left. What's my decimal gonna be? Add it to the next one, which has a mass of 40.96. What's the decimal that goes with 40.96? Good job, team. Now we're going to multiply and add. And let's see what we get. What'd you get? Hello? What'd you get? I got something closer to 39. What'd you get? That's what I got. Try your math one more time. I think you left out one decimal place. Try math one more time. 39.09 AMU is what I got. That's what I got. Check it one more time. Is this what's on the Pogil? Kind of, but not really. It's more of this. This is more along the lines of what's on the Pogil. It doesn't quite get deeper. Questions, comments, concerns. Hey, look, this is really easy down here. Number 8, flip to page 4, I think. Why is your page copy like that?
I don't know, but it's fine.
It's cute, but like, does it work? Are you good with that?
Yeah.
Okay, just want to make sure. Number 8's pretty straightforward. Number 9, it says 1 isotope of this. This is what your test and your other homework looks like. Hey, you know what? Better yet, have you guys started on that atomic mass homework in Schoology? No. I'm just gonna delete it because I think this is enough. I think this is enough practice. This, I'm going to leave it. I'm going to change the title of it, but this is what your test is going to look like. Oh. This is what your test will look like. Naturally occurring chlorine that is put in pools is 75.53% C35 this with the mass of this and this with the mass of that. Calculate the average atomic mass. That's essentially what that table is doing. It's just in word form. So I'm going to leave these here for practice, and I'm going to put this as optional, okay? Optional practice. All right, next up on the chopping block. Dang, we got through that kind of fast. Kind of shocked me. I thought we were going to be behind. Let me see what are we supposed to do today. Oh, dang. Empirical formulas. Dang it. Oh, y'all are going to hate me. At end of the unit. All right, listen, guys. We made it through almost everything we were supposed to do today. Almost. The only thing we didn't get through is empirical formulas. Empirical formulas. We'll do empirical formulas on Wednesday. That was pretty good, guys. That's also due on that's due Tuesday. I'm going to send y'all a little list. I need to post that too. Okay, bye guys. Great recording. This was fun. Had a good time. Okay, bye.